Hi, this is John Schubert, and this is a quick video on how to do Spirent Test Center testing on the RFC request for comment 2544 from the IEEE. A little bit about myself. I'm John Schubert, and I'm a senior sales engineer for Spirent. You can reach me anytime at that phone number, 760-846-8830, or via email, john.schubert@spirent.com. I do the sales and technical ends of the piece, and I work with regional sales manager Chelsea, who steps in if we need to do quotes for new equipment or renew subscriptions, support, and issues like that. So if you want to skip forward to setting up just the ports, then feel free to fast forward in this video. I like to make my videos in a format where people who don't know anything about it can get going. So with that said, I'll go ahead and get Spirent Test Center set up. So this is what Spirent Test Center looks like. This is what the desktop icon looks like when you first install the software. What this is doing is it's an application running on your PC that's going to connect to a Spirent device, application, chassis, test equipment, whatever you want to call it. This is your front end to configure the hardware on the back end. So the first thing you're always going to do is reserve the ports on the test chassis. So in this case, I'm going to use .250, which is a C1. There are devices such as the N11U and 12U, the C50s, and others that you might be using in other testing scenarios. Once you hit OK here, it's going to go ahead and reserve the ports. That's so if others are trying to use this equipment, they would see that it was reserved by you, and they would not be able to run their tests until you released your ports. So you can see over here, we've got two ports, port 1, port 2. Right now, these are an optical port going back to back. It's not actually going through anything, but for the sake of this demo, that does not really matter. So the easiest way to get started is to go to Tools and go to Wizards. There are wizards to do a number of different things. As you see here, if you're doing routing, protocol testing, there's OSPF, a couple of different tests there, some switching level things, VXLANs, things like that. And in this case, we're going to be doing benchmarking. So go down to benchmark 2544. And here it walks us through the basics of what we're going to do to set up for this test. So here's a description, 2544, benchmarking methodology used commonly for networking devices. One comment here, if you go to the RFC2544 best practices at Cisco, they want you to go into a switch and turn off any link layer discovery or STP protocol messaging. And the reason why it's doing that is because there's packets that are always come across those ports or frames, and so that can throw your counts off. You'll see your receive counts are much higher than your transmits, and that's because it's seeing that traffic and capturing it whenever a Cisco switch is trying to determine if there's a loop, like with STP, or a link that's come up or gone down with the link layer protocol discovery. So if it's a Cisco piece of gear for 2544, it's recommended that you turn that off. The test will still run, it's just, it may behave slightly different than you were anticipating. Within RFC 2544, you've got multiple kinds of tests you can run. If you Google IEEE 2544, there's a better description on what each of these are and when you would use them. So for the sake of the demo, we'll just do a throughput test. That seems to be one of the more common tests that requirements or customers are asking about. This first screen that comes up is asking about what ports that we want to use. Now I've only got 2 ports here, but you may have many more ports depending on the test equipment you've got and the ports that you have reserved on your test equipment. For my sake, there's only 2. Now at this point, you're going to configure the devices that are listening on those ports. Make this a little bit smaller. Okay, so it's already detected that these are Ethernet cards and Ethernet ports. You can also assign them to project names. So we've got port 1, port 2. Protocols, if we were doing some protocol testing, such as OSPF or different things, then this is where we would go in and we would enable things and we could go in and configure it. But in this case, since it's a 2544, leave this alone. We're not going to add anything or use anything within this pane. Here you can select your encapsulation, so IPv4, IPv6, or you can dual stack it. For the sake of this test, we'll just leave it IPv4, since that's still predominantly what most people are running. Now this is where we're getting to the brass tacks. This is where if you've got multiple ports, this wizard down here allows you to quickly configure many ports. So this is going to be your starting point. So it's saying I'm going to do the 192.185.1 network starting on 3. From that point forward on each device, and in this case we have 2, it's going to increment that last octet by 1, the way it is currently. And per port, it's going to do the first octet by 1. So that would put on 2 ports, these on 2 different networks. So for the case of this demo, we're going to change that. So I want to copy this real quickly because this is the best and fastest way to do this. So I'm only going 2 ports. I only have 1 device. So this first one's kind of moot. Doesn't matter what I put there. And just personal preference, I like to do 192.168 and do it without typographical errors. 1 dot, and I like to start on 2, leaving 1 for my gateway. Okay, so 192.168.1, the 2. And it already changed to this to .1 for my gateway. I'm going to make this 3. And what this is going to do is it's going to, what I like to do just to make it where it always passes, 2 uses 3 as the gateway, and then later I'll make 3 look at 2 as its default gateway. You don't have to do it that way, but that's just the way I like to do it. So you can verify here what you configured in the previous configured devices pane. So look through this, you can't change them here, but if you hit finish, you can change it here. So if there's columns here that you don't want to see, you can always go remove and then scroll over as applicable. In this case, I want to do 2 is 3 my gateway. That's fine. 3, I want to make 2 its gateway. Again, this is back to back, so this is mostly just personal preference. And then you can see there's a bunch of things there we don't have to worry about. So once we've done this, we're going to see over here some devices pop up. Okay, so now we have to tell it how those ports behave. So port 1, the first port, we're going to say is talking bidirectionally with port 2. So the traffic's going to go back and forth between these two. When we hit add, this is going to pop down here and you've got a bidirectional arrow. If we had hit unidirectional, you would see it's just going from 1 to 2. Now you can flip that if you want, but in this case, we're going to go bidirectional for simplicity's sake. All right, so this is where we can set in a delay that allows your ARPs and things like that to resolve successfully and not skew the results of your tests. So you can do a delay of 2 seconds. And then I'm going to disable learning since this is not going through anything layer 2 or layer 3. I'm just going to do that. And then let's say use TestCenter IQ. That's our newer results viewer. Configure throughput tests. So this is what the IEEE RFC2544 dictates. It talks about stepping through different loads, and as it goes through each load, it's going to go through these different frame sizes. So 64, 128, 256, 512, 1024, 1280, 1518. And it does the smaller ones because lately, as far as network traffic, you've been seeing more of the small packets. You want to make sure those aren't getting segmented or creating issues with the device that's under test. So at this point, we've done everything. We could just hit run, but I want to hit finish so you can sort of see what's going on. Over here on the side, you've got what's called a command sequencer. So if you automate tests, this is where you can see each step as you automate things. So in a normal workflow, you come over here, hit record, then come over and configure things on the left pane. And as you did things, it would add them here. In this case, when we did the wizard, it did everything for us. So we didn't have to create all of the steps to do the testing. So it did it for us. If this is not up, whenever you first bring it up, so say you had RFC already up and this is like this, you go through the wizard and nothing would be there. And at first you might think, well, wait, where did it go? If you come over here to view and go to command sequencer, then that brings it back. You can also pin it. And then if you move away from it, it goes away. And now that it's pinned, it won't go away whenever I click. So that's one of those little things, little neat to know, clean up your screen just a little bit. Okay, so we're good to go. And if we go over here to start, it's going to apply all those changes that we just made. So it's configuring the 2 ports, it's making them bidirectional. It's gonna ask us, how do we wanna view our results? You have the classic viewer, and we have the newer TestCenter IQ. So as soon as you do that, it's going to launch a browser. There are ways to change your default browser if you do not like Internet Explorer. I've changed mine to Chrome. So we'll just go ahead and reduce that because we don't need to look at that right now. And so now what's going on is it has started the RFC test. And if you watch it over here, it's going to be cycling through each of the loops. So it goes through the different packet sizes or frame sizes at the different rates until it gets up to 100% of the largest frame. If you're looking for errors, the next tab over, errors, comes up here. Yeah, this is basic traffic results. That comes up by default. Detailed stream results. That comes up by default. Sometimes it's nice to kind of just see something that's moving, kind of like your dashboard in your car whenever you hit the gas. So if you want to put this up here, it shows you your aggregate count for transmission. So since we only got 1 port, there's only 1, so it's not really an aggregate, it's just that port. So you can see right now we're doing 2 gigabits per second. And as this sequencer goes through the different frame rates, then you'll see the speedometer drop to 0 and then go up to the next one. So there's errors there, and then there's also detailed stream results. And it as well has error tab, so you can see errors in the frames, bits rates, checksums, things like that. So whenever it's all done, it's going to kick back open TestCenter IQ, and you'll be able to view the results of that RFC test. If you want more training on how to look at the results, just visit support.spirent.com, and you'll be able to see there how to use that results viewer and create custom reports that you can give to your resource sponsors, management, etc. So if you've got any questions, again, don't hesitate to give me a call, 760-846-8830, or shoot me an email. So thanks for your time, and I hope you have a great day.